The next program is to design a teapot in a table. Okay, so now to understand that, you need to understand what is the stack matrix. Stack matrix are intended to use with a hierarchical model. And if you want to build something within a hierarchical, that means there is a different levels of diagrams, then we can call it as an hierarchical model, and at that time we use stack matrix. It is possible to define a child object with respect to the parent body without regard to the location of the parent when the child is drawn. So this is without regard to the location of the parent when the child is drawn. So this becomes hierarchical. That means there is a child part is drawing, and whereas the location of the parent is not known, but there is a child part is being drawn. So under this type of use, we use a stack matrix. So one of the use of this stack matrix is using push matrix and pop matrix. GL push matrix copies the current matrix to the stack to the backup place, and the pop matrix copies the matrix from the backup place to the stack. Now let us understand more about this. Select which matrix stack, that means model view. Push new matrix onto the top of the stack, GL push matrix. That means the parent matrix is pushed to the stack. Now manipulate the new top level matrix. That means they add the child matrix, child diagrams, child part of objects to the parent matrix and manipulate the top level matrix. That is what. Then pop the new matrix of the stack. So done using GL pop matrix. Now let us consider a person. So there is a head and the shoulder has arms and there is a body. So you can have this child. You can see that there are different type of child matrix with the parent matrix, and this is a diagram without using a stack matrix. There is a image that is drawn. So the matrix mode, model view, load identity, that is the identity matrix, draw body, draw shoulder, draw arm, and draw head. So there is for a body, these three becomes the child matrix for a body. Shoulder, arms becomes the child matrix, and head and body becomes you can separate one. So now next, using the push matrix and pop matrix, same thing is drawn using push matrix and pop matrix. The matrix model view, load identity, push matrix, draw body, pop matrix, push matrix, draw shoulder, pop matrix, push matrix, draw arm, pop matrix, push matrix, draw arm, pop matrix, push matrix, draw head, and pop matrix. So there is as a child matrix to the body, you have drawn shoulder, arm, and arms. There are two arms. So you have written shoulder and arm. So this becomes a child matrix to the parent matrix. So this is the use of push matrix and pop matrix. The next one we understand is about lightning. So in the lightning there is ambient, specular, diffuse, and translucent. So let us look at specular. If you want, there is a more reflection. That means light falls on something and it is reflected. So then you use specular. And here, if the light falls on something and the image is viewed brightly, so then you use diffuse. And the light passes through, you use as translucent. So specular, where the light is reflected, for example, in a water the light is reflected, and in a diffuse, in a road where the light is spreaded, and in a translucent, for example, in a teapot or a glass where the light is passed through, and you can see that example. Smooth, shiny, specular reflection. So is specular. the image is reflected, and the reflection, for example, on water. And diffuse in it all direction. For example, you're going in a car and it is seen, that is diffuse. And ambient is that, for example, light, it passes through some object and it reflects through some object, and you are seeing that light through that reflection. So it is not a direct light, so you can call it as an ambient. Next one is the coordinate we consider. So in a z-axis, the 0 lies at the center of the screen, and you can see here that is 2D and this is 3D, and this 2D starts from here to the top left, and here 0 starts at the center, and it is z-axis, x-axis and y-axis. Now the aim of this program is to display this image. Now in this image, what do we see? You see two walls, and there is a floor, and this can also be considered as, this is a floor, two walls, and there is a table. In this table there are 1, 2, 3, 4 legs, and another one is there is a teapot placed on the top of the table. So we have different parts: 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are totally 9 parts in this teapot. And let us look at how we use. So this is the main program. So we have discussed in the previous classes about the initialization, glut initialization, display mode, creating a window, setting the size of the window, setting the position of the window, calling the display function, and the new added features is enabling the depth test, enabling the lightning. So we enable the diffuse light, or so for example different type of lights we discussed, and enable light 0 and set the background color. And now we select in the display, when the display function is called, we have set the values of this ambient, diffuse, specular values and shiny. All these values are set, and whichever we want, we can call it here. So when the light function FV, so light 0, so light 0 with the position, and this we can call it as the light intensity is here, and the position. And the diffuse function with selected diffuse values, these values are selected. If you want, you can replace this diffuse with ambient or specular, and the light 0. So GL light FV will specify the different type of lights with. And we have selected the matrix mode as projection, and load identity, which will load the identity matrix. Ortho, this is x minimum, x maximum, y minimum, y maximum, z near and z far. And now there are two part of function, that is wall. So wall, there are totally 9 parts we discussed. Wall is one of the part, and this is a function for a wall. And there is a solid cube, and so solid cube is scaled up, and it is translated. The translated is to position where it has to be displayed, and it is scaled down is to say what is the size of the wall. And this is a cube. Push matrix we discussed in the previous slides, and pop matrix, that is the wall. And the table leg, so this will specify what is the size of again this is the solid cube, and it is scaled up, what is the thickness of the scaled up leg, and it is translated, again it is pushed and it is popped. That means the information, this becomes parent is, this becomes a child, leg becomes a child, and wall becomes the parent. So like in a table there are legs, and legs becomes the child, and the table head becomes the parent. So you have table is called, and in the table there is a upper part of the table is here, that is solid cube with a thickness, and then these are the legs that is being called. So these are the legs that is being called, again there are 4 legs that is called on that. So let us look one example of, let's look how the program works. So now the wall function is called, the first part we started drawing the wall, and we have called the wall function. Wall function is called in this program. The wall function, wall is called here, and here it will push the content, and it is translated. It is a solid cube. It is scaled to this thickness, scaled, and it is translated to this position, and it is displayed. So a solid cube is scaled. Solid cube is scaled with x, y, z, x thickness and 1 thickness and 1. So that is here, and it is translated to this position. So this is a solid cube is formed. So that is the first wall. Okay. Now next push the this becomes the parent, and then push the values, and it is rotate the wall, the next wall into this 90 degrees. So that is rotated again. So same wall, so you have the wall which we are specifying this, and we specify this wall, and your thickness is rotated with this language. So now the next one is this is pushed that and it is rotated with 90. Let us see this. This that means we are drawing this left wall. So it is with z axis, x axis and y axis, and it is rotated with 90 degree. Let us see how it is rotated. So if you want, it is rotated in the anti-clockwise direction, and the angle theta is positive. It is rotated in anti-clockwise and the theta is positive. That means it is positive. If it is rotated anti-clockwise, it is rotated. So let us look at that how it does. So this is rotated in a anti-clockwise direction. So it is rotated. Now the wall is ready. So this becomes the parent. Again there is a push function is called. So that becomes a parent, and the child is drawn. So again there is a wall that is to be drawn on the right side. So again we take this function and we call 0.02 wall thickness, and this cube is function. You know that the function, which function is called by the wall. So it is moved. So it is moved with the x-axis. If you want to place it to the top, it is moved in the x-axis, and if it moves in the x-axis means it is in the clockwise direction. If it is clockwise direction, then the theta is in negative direction. So it is, you can see this, it is moved in the x direction, it is moved in the x direction, and the theta is negative. So it is, the wall is formed. There are three walls that is formed. So it is moved in the x direction, it is moved in the x direction, and it is 90 degree. So this is to show that how it is rotated in the x direction. Now draw the table. There are 4 legs in the table, and now here there are 4 tables, and the tables we draw the top part of the table, and there's not legs, the table top part of the table. So push matrix, the previous becomes the parent, push all the information, and draw a table to this, and the table is drawn. This function is called, and it is also a solid cube, and the solid cube is scaled with this information that is passed in the table, and it is translated, and it is from here it is translated to this position. So this cube is translated to this position, and with this scaled size, and it is translated it. The push and pop matrix are shown here. So again this part is done. So next one is draw the leg. So you need, in the table there are leg function is called. There are 4 legs function is called, and the first leg function, again this function first leg, the leg function, table leg function is called table leg push matrix. The previous all information is pushed, and then draw the table with this. It is also a solid cube, and it's scaled up like a leg. Okay, and it is translated with the length, and this is the translation. This is the length it is translated, and this is the first leg, and the next leg is shown here based on this information. Third leg, so third leg, and the fourth leg which is not seen, which is the back side. Okay, so then the next one is the drawing the teapot. So again the push matrix, the information, previous all information is pushed on the top of it, and it is the solid teapot, and this teapot is rotated with this angle, and with the y axis it is rotated on y axis with 60 degree, and it is translated and it is placed at this position. Okay, so rotated, and that means it is rotated with the y axis, so it is translated. So 0.38, that will specify here, this is the position. So the point 0.5 and 0.5, so this is the position translated to this, and it is a teapot. Thank you.